Good morning. This is your video for solving rational equations. Make sure you have finished all activities regarding partial fraction decomposition before attempting this video. It will make things much easier for you if you do. Okay. When solving rational equations, we know that we have rational expressions, which means we have denominators. In my mind, if we can get rid of the denominators, then it makes solving the rational equation that much easier. So let's begin by finding the LCD of each denominator that we have. So we have denominators of 4x and 2x. And so by way of what I showed you in class, 4 can be broken into its prime factorization of 2 times 2. X is just x times 1, and 2x is just 2 times x. And so we want to make sure that we choose common factors as well as one of every other factor that is represented. So this 2 is common to both the 4 as well as the 2, and the x is common to the x as well as the 2x. So that means we need all of these combined. So I need one common factor from the 2. I need one common factor from the x. But I also need this 2 that was not common to any of the other denominators. So that means that my LCD is going to be 2 times 2 times x, which is 4x. And so then we will change each rational expression to an equivalent one with the new denominator of 4x. So 3 over 4 will become 3x over 4x. 1 over x will become 4 over 4x. And 1 over 2x will become 2 over 4x. And if you have forgotten what we need to do in order to make these happen, then we have to look at what do I multiply by the old denominator to get the new denominator. So from 4 to 4x, I would need to multiply by x in both the numerator and denominator. For x, I would need to multiply by 4 in the numerator and denominator. And for 2x, I would need to multiply by 2 in both the numerator and the denominator. So now what we have is an expression that says 3x, or an equation, excuse me, that says 3x minus 4 over 4x equals 2 over 4x. Now that we have the same denominator, the only way these two fractions are really going to be equal is if their numerators are in fact equal to each other. So that means I'm essentially setting 3x minus 4 equal to 2. So we'll do that. 3x minus 4 equals 2. And then solve as you would your typical equation. So this says that 3x equals 6, and so x equals 2. You want to make sure that the value you get for x is not part of the domain restriction, or in other words, it is part of the domain for each of the expressions. And so the only requirements I would have on each of the original domains, if I go back to this top equation, is that x cannot be 0. As long as x is not 0, each of these individual equations or expressions, excuse me, are defined. Now, that's one way you can do this. Here's another way. Let's think about that same LCD of 4x. What we can do is we can multiply each fraction in our equation, each term, by the LCD, and that will clear the denominators out altogether. So that will look something like this. That will look like 4x times 3 over 4 minus 4x times 1 over x equals 4x times 1 over 2x. And when I multiply each term by the LCD, it cancels out, so to speak, the denominator. So this will look like 3x minus 4 equals 2. And that should look very familiar because that's the same equation that we ended up with actually here. 3x minus 4 equals 2. And then if we go through and solve, we'll receive that same solution, which is x equals 2. So you have two options. Here on the left, you can change each of the terms to an equivalent fraction using the LCD. Or here on the right, you can multiply all terms by the LCD and solve, which in turn cancels out the denominators. Method number 2 is the method that I'll be going with for the remainder of the video. Alright, so let's take a look here. We need to find our LCD. The only denominator that can be factored is x squared minus 4, and that factors into x plus 2 times x minus 2, which happens to be our LCD, considering that the first fraction has x plus 2 as a denominator, and the last fraction has x minus 2 as a denominator, and the middle fraction has both of those terms. So we will use x plus 2, x minus 2 as our LCD, and as I said, I'm going to go through and multiply each term by that LCD. So I have x plus 2 times x minus 2 times x over x plus 2. And then I have minus x plus 2 times x minus 2 times 8 over essentially x plus 2, x minus 2. And then that would equal x plus 2 times x minus 2 multiplied by 2 over x minus 2. And so what happens here is that the denominators will divide each other out, equal 1. Essentially they cancel. So x plus 2 cancels x plus 2 here. X minus 2 cancels x minus 2 here. X plus 2 also cancels x plus 2 there. And then in the last fraction on the other side, the x minus 2 cancels the x minus 2. So what I'm left with is x times x minus 2 minus 8 equals 2 times x plus 2. Let's do some nice distributive property. This becomes x squared minus 2x minus 8 equals 2x plus 4. I cannot solve a quadratic equation in this form. I have to make sure one side of the equation is 0. And so I will move terms to the left side through opposite operations in order to make that happen. So this becomes x squared minus 4x minus 12 equals 0. Now I can look to factor. This polynomial factors very nicely. It factors into x minus 6 times x plus 2 equals 0. The zero product property says that one of these factors, if not both, must equal 0. I'm not sure which one, so I'll set them both equal to 0. So I have x minus 6 equals 0 or x plus 2 equals 0. Solving on the left, I get x equals 6. Solving on the right, I get x equals negative 2. If I go back and look at domain restrictions, x cannot equal 2, x cannot equal negative 2. If either of those values are used for x, then I have denominators which would equal 0, which would lead to rational expressions that are undefined. So that means this x equals negative 2 solution is what we call extraneous, meaning that we got it algebraically, but it cannot be used as a value of x. So our only solution is x equals 6. We'll have no problems with that one. Last slide coming up. This one looks a little interesting. So let's take a look at the LCD. I have x minus 1, I have 1, and then I have 1 minus x squared. I'm going to challenge you to write this as negative x squared minus 1. And that means that I can treat this as, I can rewrite this equation as 3 over x minus 1 plus 4 equals negative 1 over x squared minus 1. Again, that's understanding that I can factor out a negative 1 here to change what this expression looks like. I'm now applying that same negative sign here to the numerator of this last fraction. So if I continue factoring here, then I'm going to use this as x plus 1 times x minus 1 for the x squared minus 1. So my LCD is x plus 1 times x minus 1. Multiplying each term by that LCD, I have 3 times x plus 1, considering the x minus 1s will cancel, plus 4 times x plus 1, x minus 1, equals negative 1. The x squared minus 1 in that last fraction is the same denominator as our LCD. So distributing, I now have 3x plus 3 equals 4x squared, or excuse me, plus 4x squared minus 4 equals negative 1. Remember that with quadratics, we can only solve them if one side of the equation equals 0. So combining like terms and moving the plus 1 to the other side, I have 4x squared plus 3x. 3 minus 4 is going to be negative 1, and I'm going to add a 1, so that's going to be a 0 there, so this equals 0. Factor out your x. We have x times 4x plus 3 equals 0. So either x equals 0 or 4x plus 3 equals 0. Solving for x, we have x equals 0 or x equals negative 3/4. If I go back and look at domain restrictions, x cannot be 1, x cannot be negative 1, and neither of these values violate that domain restriction. So in this case, I do have two solutions, either x equals 0 or x equals negative 3/4. That concludes your lesson on solving rational equations. Please download the worksheet and begin working on that. And later this afternoon, I'll do one more on solving rational inequalities. Stay safe, stay warm, and I'll see you guys in a week.